See, because when you talk about physics, right, if you pre-read it, if you watch the videos before, it will be much clearer in the concept, right, when we will teach in the classroom. Okay, because you will get to know what you couldn't understand in the video. Okay, plus revision of what we have studied in last class. So I hope everyone remember whatever we studied in last class. Tell me, everyone remember that? Just raise your hand, everyone. Yes. Okay, very good. Okay. Now, some of you asked about the notes. Okay, so what I'll do is I'll just upload the PPT. Okay, I'll upload the PPT. I'll make a PPT because see, notes would be scrambled because my handwriting is very bad. So I will share that also. Plus, I'll share the PPT. Okay, which I'll make for all the concepts. I'll just upload the PDF, OS. I'll just upload the PDF. Okay. Okay. So I guess everyone remember what we have studied in last class? Tell me, anyone? DC, yeah. In Need Google Classroom, I have uploaded whole book. Okay, I'll upload the same book in JE also. Okay, I've already uploaded the book in Need to Batch. Right, everyone? So let's see. Now, when we talk about this topic, right, gravitational force and gravitational field, we discussed about gravitational force. Okay, we discussed about gravitational force. What is gravitational force? Let's start with a pre-reading. Let's see how many of you have at least pre-read and revised the concepts. So tell me, this is the concepts that we have studied, right, in previous chapters. The first concept is the angular momentum of the system is always conserved when the net force acting on it is zero. Tell me, true or false? Okay, Malik, very good. Okay, Pranjal. Okay, think about it. Think about it. What is the definition of force? What is the definition? What is Newton's second law? Think about it, right? And what is asked, right? Angular momentum, not linear momentum. Okay, right? Okay, I got enough answers. Question number 2. What do you think? Question number 2. During pure rolling, the friction acting on the point of contact is pure rolling, right? Okay, very good, Anisha. Very good. Nishita, very good. Okay, everyone know this concept. Okay, everyone getting the same answers. Third, in the case when rolling sphere slows down due to rolling friction, the normal reaction shift away from the center passes from the center. Third, this is the concept of last chapter. Okay, okay. Fourth one, the position vector of particle having linear momentum p with respect to a fixed point O, right, is r. The angular momentum is given by, this is basic formula putting getting. Fourth one is basic formula putting getting, right? Okay, very good. So everyone remember, very good, right? Fifth one, last one. In case of rolling with forward slipping, okay, with forward slipping, right? Vcom is less than r omega. True or false? Okay. So let's see the answers, right? Let's see the answer, guys. First is false. First is false because it is angular momentum, right? Angular momentum, torque, net torque, tell me, should be 0, yes or no, right? Agree? According to definition, net torque should be 0 for angular momentum, yes or no? Yes or no, right? I hope all of you remember the examples when the net force was 0, but net torque was not 0, right? In that case, angular momentum will not be conserved, right? Okay, because we use the angular momentum conservation equation only when torque is 0. Next, so most of you have answered this correctly. Static, very good. Third A, shift away from the center. It is again theory. Fourth, most of you have answered correctly. R cross P. And fifth, false, right? Okay, very good, everyone. Now, when we talk about the concepts that we are going to study today, right? The concepts that we are going to study today are first, what is gravitational field, right? What is gravitational field? Okay, and how to calculate this gravitational field due to different objects. Okay, so primarily we'll be focused on this first concept only. The second, third, and fourth concept are basically variation of G, right? Variation of G due to height, depth, and rotation of Earth. Okay, now let's talk about gravitational field. What do you mean by gravitational field? Let's think about gravitational field. Tell me, what do we mean by gravitational field? Anyone? Anyone? What is the meaning of gravitational field? We have already discussed this, right? We have already discussed what is the meaning of gravitational field. Tell me, anyone who remember this concept from last class? Yes, so I can say that this is the space, right? This is the space or the area where one object, suppose we have an object, right? This object of mass m, okay? Experience of force, right? Okay, right? So the area or the space, right? Right? Up to which this object, right, of mass m has its effect, right, everyone? Has its effect. So it can extend up to infinity, no issues, but the strength will vary, right? Strength will vary. So this is, okay, this is the intuitive definition. This is the intuitive definition. What about the mathematical definition? So can I say that this field, right, or gravitational field intensity, both are same, gravitational field or gravitational field intensity. Okay, so I'm just writing it as Ig, okay, right? Ig. So Ig can be said as this is the force experienced, right? Force experienced, right, on per unit mass of the system, right? Force experience per unit mass, right? Got it? Yes or no? Tell me. Yes or no? Yes. So gravitational field intensity, as we know, it is the force experienced, which force? Gravitational force experienced by, tell me, a unit mass. Okay, right? So it is the gravitational force per unit mass. Now, when we talk about this gravitational field, don't you think that this is a vector quantity? Yes or no? This is a vector quantity. Tell me, is it a vector quantity? Yes, very good, right? Obviously, it is a vector quantity. Now, what is the formula of this electric field? Right? Gravitational field intensity. Sorry, I'll just, I'm used to use this electric field. Okay. So when we talk about this, okay. So this electric field, sorry, gravitational field, since I'm from electrical, I'm just in habit of speaking electric. Okay. So the formula of force, right? What it was, G capital M, small m, right? By, tell me. Now, I want to find the gravitational field intensity due to capital mass m, right? Right, everyone, due to capital mass m, right? I want to know how much force this capital mass M, right, can exert on any other mass. Yes or no? Tell me, yes or no? Or I'll just say it as M1, and here I'm writing M1 and M2. Okay, so if I want to find, right, the force exerted by M1 or any object, right? So on which object force is experienced? Tell me, on which object force is experienced? M1 and M2. M2, right? Okay, I want to find the force. I want to find the force on M2 due to M1, right? Because I want to find the intensity, gravitational field intensity due to M1. Got it? Right? Due to M1. So I can say that it is force due to M1 on M2 by M2, right? Got it? By M2 into this force is R square, right? M2 M2 cancel. So we will get what? G capital M or M1 by R square. Now, since it's a vector, right? Since it's a vector, it will be again R cap. Now, don't you think that this formula is almost same as force formula? Yes, this formula is almost same as force formula. The only difference is when we talk about force, right? When we talk about force, we need two mass M1 and M2, two objects of mass M1 and M2, right? Now, when we talk about gravitational field, right? Gravitational field. So I can say that, okay, gravitational field, right, is basically the field created by mass M1, right? Created by mass M1. I'm just showing it like this, okay? And because of this, right, the force is exerted on mass M2. Yes or no? Can you feel like this? Tell me, yes or no? Everyone, just tell me, are you getting this concept, right? Or if you want to visualize this, right, suppose, because this might not be very visual, so just think about two magnets, right? You can just think about two magnets if you want to visualize. Okay, now if you have this magnet, right, M1. Now if you keep this magnet, right, if you keep this magnet at certain distance, then the second magnet will attract, yes or no, right? All repel depending upon the polarity, but I'm considering that it will attract, right? So can I say that when this magnet of mass M2, right, okay, or any magnet, right, comes under the field of this M1, it will experience a force, right, which will make this magnet to come closer, right? Or I can say that this magnet M1 will attract this magnet M2, right? Yes or no? So my next question would be, suppose I remove this magnet, right? Suppose I remove this magnet, then the field, of this M1 will disappear or not? Tell me, if I remove this magnet M2, then the field of the magnet M1 will disappear or what? It exists, right? It exists, it will still exist, right? So I can say that, field is the, yes, field is the property of one object, right? Because field is the area, right, up to which that object have its effect. Okay, that's why when we talk about gravitational field, we will consider only one mass. Okay, because I want to know what is the area, what is the space up to which that mass can have its effect, right? Everyone, tell me, right? Anyone have any issue in this? Anyone have any issue in this, or is it clear to everyone? Okay, because I've already given you the idea about fields in last class. So let's see. So I can say that, just see this, I can say that gravitational field strength at any point is basically the gravitational force exerted on unit point mass, right everyone? Unit point mass. Okay, so as I said, right, So the strength is F by M. Now we know this if we remember the formula. Okay, if we remember the formula of gravitational force, right? F is equal to mg. So can I say that G is equal to F by M? G, right? Wait, everyone. Yeah, G is basically F by M, right? So this G that we have studied, right, is acceleration due to gravity, okay, right? But according to this definition, it is your gravitational field strength or gravitational field intensity. Agree? Anyone have any issue in this? Tell me, anyone have any issue in this? Is it clear to everyone? Now, when we talk about the dimension of this, right? So basically it is force by mass. So what is the dimension of force? I hope everyone remember what is the dimension of force. ML, tell me. Mass into acceleration, right? ML t to the power minus 2. This is the dimension of force by mass m. So it will be what? M to the power 0, L t to the minus 2. I hope everyone know how to find the dimension, right? And units. In the first chapter, unit dimension, you have already studied that. So I need not to tell this, but still you can find the dimension as well as units, right, everyone? Okay, very good. Now, when we talk about the electric field, sorry, my bad. Sorry guys, I've studied this for 5 years, so that's why I'm in habit of speaking electric field all the time. Okay, okay. So when we talk about gravitational field, okay, so first thing when we say it is the effect of an object. Now that object may be a point mass, right, or maybe a continuous mass, right, everyone, right? Okay, so the formula will be same, right? The formula will be same. Doesn't matter if it's point mass or it is continuous mass. The formula, right? The basic definition of gravitational field will not change. Agree? The basic formula will not change. It will be force per unit mass only. Okay. Now, as I said, right? For point mass, it is always F by M, right? Which is force per unit mass. Got it, everyone? Tell me, got it? So this is the formula. This is the formula for point mass. GP means point mass. I hope everyone is clear about this, right? Okay. And since it's a vector quantity, the direction, right? The direction is always, tell me, away from the object or toward the object? Tell me, guys, the direction will always be away from the object or toward the object? Yes, very good. Toward the object, because it is no, not Sneha. It is always attractive, right? Just think about this. Suppose we have two objects. Okay. Now, this object M1 and this object M2. Okay. Right. Now, this object M2 will experience a force, right? Experience a force in this direction. Okay. So this force is away from this object M2, right? Okay. But what about this M1? It is attracting this. I'm talking about the effect due to M1, right? Got it? So it is attracting. If it is attracting, the electric field, sorry, the gravitational field should be, right, toward M1. Yes or no? Toward M1, right? Agree? Okay. So if I'm saying that this is R12 cap. This is R12 cap. Okay, just think about it. This is R12 cap, right? So what will be GP vector? It will be what? G capital M1, because I want to find the electric field due to M1. I want to find the electric field due to M1. Okay. Right? By R squared into R12. Now tell me, what is wrong in this formula? Tell me, what is wrong in this? Yes, it should be R21, right? Or we should have minus sign over here, right? Gm1 by R square into R12. Okay, because the direction of R12 is in this direction, right? But the direction of electric field is in this direction. So this is something that you have to focus. Okay, everyone, got it? Tell me, everyone got this? Right? Okay, very good. Very good, everyone. Now, whenever you have a doubt in electric field, just think it as gravitational field, just think it as gravitational force. Okay, so can we use superposition principle here? Tell me, can we use superposition principle here? Yes or no? Yes, right? Means suppose I'm having this case. Just think about it. Okay, suppose I'm having this figure and I want to find, so we have this mass m1 over here, mass m1, this is mass m2, this is mass m3, and this is mass m4, right? Okay, I want to calculate the gravitational field, G at the center, right? At the center. Tell me what it would be. And if all the masses are equal, if m1 is equal to m2 is equal to m3 is equal to m4, if all the masses are equal, then tell me what will be the G, what will be the G? It is square, okay? It is a square of side A. Think about it, you don't have to calculate, right? Yes, very good. It will be 0, right, everyone? It will be 0. Because if, yes, and you don't, you don't need a mass at the center, right, everyone? You don't need a mass at the center, right? Because you are calculating the electric field, not electric force, okay? And the electric field will be due to these masses, m1, m2, m3, m4, okay? Right? And because of m4, electric field is in this direction. Because of m2, it will be in this direction, so they will cancel out, right? Because of m1, it will be in this direction. Because of m3, it will be in this direction, and they will cancel out, right? But if mass m1, m2, m3, m4 are not equal, then you can easily calculate. Yes or no? Tell me. Then you can easily calculate, right? Obviously, you have to put the formula gm by r square, right? Since r is same, okay? You just have to put the formula and solve. I hope if you have understood the last class lecture, it will be easy now, right? So everyone know how to find the gravitational field due to a point mass? Tell me yes or no? Yes or no? Okay, very good, everyone. So when we talk about gravitational field, okay, so the first is point mass. Field due to point mass. So this is quite easy, right? So basically G due to point mass is equal to capital G m by r squared into r cap. As simple as that, right? Anyone have any issues? No? So this is the the gravitational field due to mass m at a point P, which is r distance away from this mass. Okay, this is the meaning of this. This is your first case. Now, second case, just think about second case. So second case, I'm taking sphere, right? I'll just go in the order of difficulty, sphere, and that too, hollow sphere. Now, what is the meaning of hollow sphere? Tell me, what is the meaning of hollow sphere? right? Means it is thin spherical, right? It is a thin spherical shell. It is your thin spherical shell. There's nothing inside that sphere, right, everyone? There's nothing inside that. Okay, right? Now, I can say that, okay, I want to find the electric field, sorry, gravitational field. I want to find the gravitational field. That's happened when you study electrical engineering for 5 years. Okay, so I'm having two cases, right, everyone? Because when you talk about the distance r, okay, so I'm having two cases, which is case one, right? And the radius of, suppose this is a radius of this is a. So case one and case two. Tell me what would be the cases. Tell me, everyone, what would be the cases? What is case A? What is case B? Intuitively, what do you think? If I want to find the gravitational field, right? We agree. So I can say that here we have 2 points, right? One point which can be inside the sphere, one point which can be outside the sphere, right? So case one is r is less than a, and second r is greater than a. Agree, right, everyone? Okay, now think about this. If you talk about any point inside, right? Any point inside this is point A, inside the sphere. Now, do you think that there's any mass inside this sphere? Do you think that there's any mass inside the sphere, right? Now, if there's no mass inside this sphere, right? If there's no mass inside the sphere, will there be electric field? Think about it. Will there be electric field? Because there is no mass, right? Okay, so no. So I can say that the gravitational field, I don't know when I'll just stop speaking electrical field. Okay, guys, whenever I speak electric field, right, just assume it to be gravitational field. Okay. Okay, so the G, right, will be 0, right, everyone? Okay, are you getting? Everyone have understood this concept, right? Okay, now second case, when we talk about any point which is outside this sphere, right? Just take about this point. This is point B. Okay, point B. Now, when we talk about this point B, now for this point B, this distance is again R, as I said, this distance is R. Now tell me, the formula will always be same, right? The formula will not change. G is equal to capital Gm by R square. Agree? Tell me, agree? Now for this point, the mass will be total mass, right? The mass is total mass, right? Agree, everyone? Okay. Now one can argue, so how can it be? Because when you talk about this point, it is nearer to this point B, and when you talk about this point, it is far than point B. So the thing is, right, if you calculate, even using integration, right, it will cancel out. It will cancel out, and you can assume that for this hollow sphere, all the mass is present at its center. Okay, right? So I just write the formula of electric field same as point mass, okay, which is our distance from this point B. Okay, okay, everyone, this is for hollow sphere. Anyone have any issues? Tell me, anyone have any issues till this point? No? Okay, very good, very good. So hollow sphere clear? Chulika, Samya, Pradyumna, Angha? Okay, very good. Right, step by step. Now, after this, after hollow, right, let's talk about solid sphere. Solid sphere. So what's the meaning of solid sphere? I hope everyone know what's the meaning of solid sphere. It means it is made up of mass, right? It is not hollow inside. It is just made up of something, mass, be it anything, right? It is total spherical mass. Now, when we talk about solid sphere, before solid sphere, we should know what is mass density, right? Mass density. Let's write here. Mass density. Okay. Now, I hope all of you remember lambda. What was lambda? It is mass per unit length, right? This is your linear mass density, right, everyone? This is your linear mass density. In the same way, right here, and we have rho, which is mass per unit volume. Okay, right? So we have three type of mass densities: linear mass density, area mass density, right? Or surface mass density and volume mass density, right, everyone? Anyone have any issue? Tell me. Anyone have any issue in this? No? Okay, all of you understood what is your volume mass density, surface mass density, and linear mass density? Okay, very good. Now think about it. Think about it. I'll just make one more sphere. Now I'm having this sphere, right? I'm having this sphere, but this is not hollow. This is not hollow. Okay, we have mass inside the sphere, right? So again, here also we can take two cases. So I'll just take first case one, the easier one, case one, right? When r is greater than a, again a is the radius. A is the radius. Now tell me, what will be the formula for g? Tell me, guys, what would be the formula for g? Mass of this is capital M. Mass of this solid sphere is capital M. Tell me, what would be the formula of G when you take any point R which is outside this sphere? Tell me. Yes, very good, Karishma. It will be same, right? Because if a point is taken outside the sphere, then the sphere is treated as point mass, right? Yes, very good, everyone. So it will be same G capital M by R square, right? I'm just talking about, right? Any point outside this, okay? Point A. Now, when we talk about any point inside, right? Let's talk about any point inside. So yeah, let's talk about this point, right? Let's use yeah, let's talk about this point over here. Suppose this point is B. Okay, so this point is inside this, right? This point is inside this hollow, sorry, solid sphere. Yes or no? Yes or no? Tell me, think about it. This is actually very easy. If you actually think, right, it is very easy. Now, case 2, when I'm talking about case 2, case 2, where R is less than A, right? R is less than A. Now, don't you think that the formula should be same, right? Why the formula should change, right? The formula of G should be same, right? It should be G M dash by R square. Agree? Tell me, agree? Or I'll just write it as G dash. Don't you think that the formula should be same? How can the formula, right, the basic formula, right, it won't change. The basic formula will not change. It will be same. Now tell me, what has changed here? Tell me, what has changed here? What do you think? Think about it. What has changed over here? If you take this point B, for point B, what is the mass now? Tell me, what is the mass now? Mass is the mass of this small red sphere. Yes or no? Tell me. The mass is, yes, M dash, which is the mass of this right? Red sphere, right? Mass inside this red sphere. Okay, agree? Now, can you find m dash? Can you find m dash? M dash, right? Sneha, just think about it now, right? Just think about it. When you take this point B, just take this point B. For this point B, right, the field will be, right, the field will be for which mass? The mass which is inside this red sphere, yes or no? Tell me, yes or no? Got it? That is your m dash, right? So can I say that m dash is the mass, right? M dash is the mass of the red sphere, right? Which is basically the sphere having this distance r as your radius. Yes or no? Tell me everyone, yes or no? Right? Okay. So I don't have to do with this, right? I don't have to do with this bigger sphere. I want this small sphere because I want to find the electric field at this point B, right? Now I want to find m dash. Now what is the volume of m dash? Tell me, what is the volume of m dash? V dash is equal to what? Think about it. What is V dash? Volume of this, volume of this red sphere is V dash. What is the volume? Volume of sphere formula. Tell me, everyone. Samarth, if you are taking any point B, right? If you're taking any point B, just think about it now. If you take any point in any direction, the magnitude would be same now, right, Samarth? Right? Tell me, yes or no? And here I'm talking about the magnitude, right? Okay, so obviously it will form a sphere now, right? Because when talk about distance r, so distance r can be in any direction, right? And if you rotate this vector r in any direction, it will form your sphere. Okay, got it? So obviously it will be concentric sphere now, right? Everyone got this? Okay, very good, Samarth. Understood why it will be concentric sphere? Okay, so v dash, yes, very good. So it will be 4 by 3 pi r cube. Anyone have any issue in this? Anyone have any issue in this? Yes, very good, Avas. Right? Very good. And what is the total volume? Tell me, what is total volume? What is total volume? 4 by 3 pi a cube. Step by step, step by step. Anyone have any issue till this point? Anyone have any issue till this point? Now, don't you think that the density will remain same? Doesn't matter at which point you are taking, right? The density of the object, right, should be same now, right? So if you're taking red sphere or this black sphere, the density should be same, right? Rho dash should be equal to rho. Okay, right? Rho dash should be equal to rho. Now what is rho dash? Rho dash is m dash by v dash should be equal to capital M by capital V. Anyone have any issue in this? Or capital M by capital V? Anyone have any issue in this? So m dash is equal to capital M into v dash by v. Getting the concept, guys? Easy. Think about it. Mansi, Samya, step by step. Smriti. Now I'll just put the value, right? M dash is equal to capital M into v dash is 4 by 3 pi r cube divided by v is 4 by 3 pi a cube. 4 by 3 pi, 4 by 3 pi cancel, right? So I can say that m dash is equal to capital M into r cube by a cube. Anyone have any issue in this? No, right? Now, don't you think that this is quite easy? You just have to put this m dash now, right? So what is g dash? G dash is equal to g m dash is capital M r cube by r squared into a cube. Okay, now after cancelling, you will get this formula, capital GM R by AQ. G dash is equal to. Yes or no? Tell me guys, yes or no? Yes or no? Anyone have any issue in this? No? Okay, very good everyone, right? Now let's see the graph, right? Let's see the graph. Okay, so let's see the graph. Now when you talk about, I'll just write it here. Hollow, solid, okay, right? Now when we talk about graph, so what is a graph? Graph is basically the variation, right? The variation of gravitational field over the distance. Now suppose this is 0 origin, which is the point of, right? This is 0, which is your center. And suppose this is A, which is the radius. Now don't you think that from 0 to A, what about hollow sphere? What is gravitational field from 0 to A? Field is 0 to A. Gravitational field formula is 0, na? Yes or no? Tell me guys, yes or no for hollow sphere? Okay, so we won't have any. So this is variation of G with R, G with R. Okay, now after this, right, from A to infinity, G is, tell me, capital G M by R square. Inverse square law, right? So suppose this is this value, suppose this is this some value. After this, it is inverse square law. So it is like this. Agree? So this is the graph of G with respect to R. Right, everyone? Tell me, right? For hollow sphere. Okay. Now, what about solid sphere? Tell me, what about solid sphere? Now, when we talk about solid sphere, right? Think about it. Again, this is point of origin. This is A. From A to infinity, it will be still same because we know that for A to infinity, G is same. G, the formula of G is same. G M by R square, right? So it is same as hollow sphere. Okay. Now what about 0 to A? 0 to A. The formula is G is equal to capital G M R by A cube. Now don't you think that G is directly proportional to R? Yes or no? G is directly proportional to R. Agree guys? Right? So can I say that the graph will be something like this? Okay, so this is the graph of solid sphere, right? Because from 0 to A, it will increase linearly, right? This is R and this is G. Anyone have any issue in the graph? Tell me guys, anyone have any issue in the graph? Okay, very good. Okay, very good everyone. Clear? Very good. Okay, now after sphere, see there are many things, right? But what you want to like, so what is in your syllabus, that is important, right? So after this we have ring. I'll just ring, go in the order of difficulty. Okay, right? At infinity it will be almost zero, na Sania? Just think about it, na? At infinity, right? Just think about it. If something is very far, right, will it have its effect on that object? Think about it. That is the meaning of infinity, right? Can you hear my voice, right? Without phone, can you hear my voice from here to there? No, right? So obviously that distance, right, is infinity for you, right? So basically infinity here means the distance at which any object will not have its effect, as simple as that, right? It may be 1 kilometer, it may be 2 kilometer, it may be 100 kilometer, right? It may be 1000 kilometer. So infinity is just a point at which any object will not have its effect. Okay, right everyone? Understood? Now we will derive in this normal class, we will derive only for ring. We will not derive the formula for disk. Okay, we will not derive the formula for disk. Why? Because it is in advance, it is not in means and neat. Okay, right? It is in electric field, it is not in gravitation. When you talk about gravitation, when you refer any book, okay, they won't derive all the formulas. Okay, I hope all of you, some of you have already referred some books, right? Anyone have referred some book? BM Sharma or Arihant? Now, did you get, yeah, did you find the derivation of any of gravitational field due to this masses, continuous masses? It is in question, it is in question, okay, right? Yeah, Epsilon is there. So we'll be doing disk, okay, we'll be doing disk in advanced class only, right? So here ring. Now when we talk about ring, what is ring? Tell me, what is ring? So ring is something like this. Wait, I'll just draw using this. I'm horrible at drawing. That's what I said, Abhiram. So ring we will discuss. Okay, disk we will discuss in advanced class. Okay, because it will create confusion for NEET students. Okay, because lots of maths is involved in that. So ring, all of you know, right? Ring is just like circular figure, right? Okay, so it's like this. Now, suppose I want to calculate the gravitational field because of this ring at point A, okay, which is d distance away from its center, How to do that? Think about it, right? Step by step, think about it. Again, we have to write basic formula. Yes or no? We have to write basic formula. Start with basic formula. Start with writing basic formula. Okay, so basic formula is what? G is equal to capital G M by R square. Right, everyone? Right? Okay. Now, here, which mass we are taking? Because it is not a point mass, right? That's my problem. This is not a point mass. Okay. Now, my problem is this is not a point mass. What to do then? What to do? So, this formula, I cannot write because this formula is for point mass. This is only for point mass, right? And here we don't have point mass, right? It is continuous system. So I need to take one small portion, which can be considered as point mass. So I'll just take small portion and the mass of this portion is dm. Agree? Agree, everyone? You don't have to take dx in this case. Okay, you don't have to take dx in this case. You can just take dm. I want dm, the small portion. The mass of that portion is dm, right? Dx is the length, right? I just want to know the mass of that portion. Agree, everyone? Anyone have any issue in considering this? Okay, now can I say that, okay, if this is my mass, so now dm, sorry, dg, because obviously this will be dg, na? So dg is basically g into dm by r square. Agree? Right? Now next question is this radius is given as, suppose this radius is given as a. What is this r? What is this r? Tell me, what is this r? This r is always the, yes, it is always the position, right? Always the distance from the mass to the point, right? From the mass to the point. Okay, right? So distance from the mass to the point. Now tell me, what is the distance? What is the distance from the, what is the distance from the mass to the point? Tell me, everyone. Think about it. Tell me. And it's a vector, so we will have r cap. Tell me, everyone. Step by step, what is this r? What is this r? Guys, Pythagoras theorem, right? Pythagoras theorem, na? Right? I'll just use red pen. So this is this distance. Yes or no? This is this distance. So it is a square plus d square. Agree? Anyone have any doubt in this? Tell me, anyone have any doubt till this point? Understood what is dm, what is r, step by step, right? Okay, very good. Now, what do you think? What is changing? Think about it. What is your variable over here? What is your variable? Tell me, what is your variable? Is r your variable? Yes or no? Just think about it. Is r your variable? Now, before answering, ask yourself, is r changing for any point on the ring? Any point of the ring, r is changing? No. So think about it. If r is not changing, how can it be variable? Yes, I'm talking about magnitude only, right? Okay. If the magnitude, if the r is not changing, how can it be a variable? It cannot be a variable, right? That's the way to know what is your variable. Okay. So certainly r is not a variable because r is under root of a square plus d square. A is constant, d is constant. So certainly it is not changing, right? It is not changing. Only direction is changing. Okay. Right? Now tell me, if r is not a variable, then what is a variable? Because whenever you integrate, right, this is for NEET students, specifically for NEET students, the normal issue that students face, right? What is the element to integrate, right, everyone? Okay, what is the element to integrate? That is the problem, because some of you were saying, sir, dx, because we have taken dx in one case. But here, it is not required to take dx because this distance is not varying at all, right? Okay, right, everyone? So this is your dg, this is your formula, m is varying, okay, done, right? R is constant, r will not be integrated, done. Now, is there anything else? Is there anything else? Think about it. Think about it. This is not just a question, right? This is a concept. How to take the elemental area. Okay, we will be using the same concept in electric field. Same thing, exactly the same thing. Instead of mass, we will have charge. Now, if I ask you, what will be the direction of this gravitation field? Tell me, what will be the direction of this gravitation field? It will be this, right? Yes or no? Tell me, yes or no? Think about it. Yes or no? This red line, yes? Agree, everyone? Okay. Now, can I break? So this is your G vector. This is your G vector, right? Or basically DG vector. Okay. right? Small section of G vector. Now, can you break down this into two components? Think about it. Can you break it down into two components? This angle is theta, so this angle is also theta using vertically opposite angle, right? So I can say that dg vector in x component, right, is dg cos theta, right, and dgy. Now tell me, what is dgy? Tell me. Dg sin theta. No, Samarth, right? It is a vector, so the vector is always, right? Vector is always in the direction of its position. Nah, think about it. Yes or no? Think about it. That is the concept, right? That the concept that student miss. Okay, if the mass is at this point, think about it. If the mass is at this point and the r is like this, r is like this, the red line. So obviously dg will be in this direction. Nah, yes or no? Tell me. These are the very small concepts that you have to focus. Got it, Samarth? Right? Because I know that most of you might be thinking, so the dg should be in this direction, right? But dg will not be in this direction now, because this is your position vector, right? This red line is your position vector. Yes, it will be in this direction. I'm just showing you like any like random direction. It will be in this direction. I'm just showing you this. Okay, I'm not showing any direction like negative, positive. Okay, so this is in this or this. I'm just talking about the magnitude. Okay, even if it will be this, so it will be in this direction. Okay, wait, in this direction and in this direction. Okay, right? Okay, fine now. Tell me, fine now. Okay, apologies, I was again, right, because of electrical, when we talk about electric charges, right, it will be in that direction of the same charges. That's why I'm used to that. Okay, but you understood, right? So magnitude wise it will be same. The direction might will change, magnitude wise it is same now. Dx is dg cos theta and y is dg sin theta. Now don't you think, suppose if you take dm throughout the circle, what will happen to this y component? Tell me, what will happen to y component? Suppose this is dm at this point. When you take a dm at this point, okay, just take dm at this point, right? Then dy is in this direction, dgy will be in this direction. Yes or no? Tell me, yes or no? So it will cancel each other. Agree? It will cancel each other. Means every point on y-axis will have their opposite side, which will cancel each other. Yes or no, guys? Tell me. Think about it. Think about it. Step by step. Mansi, Anisha, Anjali, Chulika, Aryan, Karishma, Jitendra, Koshi, Meet. Are you getting? Right? Because if you take any point on this ring, any point, take this point, right? Take this point, right? It will have this opposite point. So y-axis, this will have, right, this dy vector, dgy vector, right, will always have its complement, right? Okay, always will have a vector which is opposite in direction. So this will become zero. This will become zero. Yes or no? Tell me. Yes or no? Means the gravitational field in y direction will be zero. So I can say, okay, net will be in x direction only, right? But that net will not be this. That net will be this. Okay, right? Got it? Got the concept? Tell me, this concept everyone got? Agree? Anyone have any issues? Okay, so let's try to solve it. So dgx is just gx after integration. It will be just gx, right? And this is what? This is capital G dm by r square into cos theta. What is cos theta? Tell me. Cos theta is equal to base by hypotenuse. Yes or no? Base by hypotenuse. What is base? Base is d and hypotenuse is a. Sorry, hypotenuse is r. R, right? And every of them, right? Every term r, d, r are constant, right? And this is your integration. Okay? Integration 0 to capital M, mass, because you are integrating mass, right? So it will be what? G d by r cube into integration of mass is capital M, as simple as that. If you integrate mass throughout the ring, you will get capital M, na? Total mass. So this is the formula, G capital M d by r cube, right? So this is the simpler one, right? Into r cap. Now if you think, it is basically this, G capital M d by a square plus d square to the power 3 by 2. Right, everyone? I hope all of you remember this formula. Tell me yes or no. Yes or no. Understood this? You just have to remember this formula, and this is r cap. Clear? Clear, everyone? Which step, Kashma, tell me which step I have to repeat? R is root of a square plus d square, na? So I just substituted that, okay? I just substituted it, okay? We will integrate mass dm. So mass on integration throughout the ring will give you total mass, which is capital M, right? And g d by r cube is a constant, right? So it will be taken outside. So this will be your answer, right? And I just put r is equal to root of a square plus d square. So I will get this as your answer. So this is the formula of gravitational field intensity or gravitational field strength due to ring along the axis. Okay, everyone? Tell me, okay? Now, tell me, what will be the G at the center of the ring? Tell me, what will be the G at the center of the ring? G at the center of the ring. At center of the ring. Center of the ring means D should be equal to 0. So obviously G should be equal to 0. Got it? Yes. 0 na somewhere, because it is, see, it is 0. Gm into 0 by anything is 0. Okay. Anyone have any issue in this? Tell me, anyone have any issue in this? Tell me, guys. Okay. Okay, everyone. Now, I'm giving you two derivation as a homework. Okay, two derivation as a homework, because for NEET students, you just have to remember the formula. Okay, and for JEE students, you have to derive, right? So this is homework. Write it down. Okay, class will continue. Don't worry, right? But this is the homework you have to find. Okay, find the gravitational field G for finite mass of length L, mass of length L and mass M, capital M, right? So at given point. Okay, so this is your mass, and you have to find at this point P. Okay, this point P, which is making an angle of alpha and beta, right? Wait, just shift it over here. Okay, so this is angle alpha and this is angle beta. This is D. This whole length is capital L. The whole mass is capital M, right? Okay, find G in X direction and G in Y direction. Okay, right? Got it? Guys, got it? It is homework. So if you remember the last class, okay, it is same as that. Spherical shell, which spherical? Hollow or uh, solid sphere? See, hollow sphere, when you talk about hollow sphere, right? Okay, there's no mass. Now, if you take any point inside the hollow sphere, right? So when you consider that point, will there be any mass? Will there be any mass which will attract that or have its effect on that point? Because, right, we should know that we require a mass which will pull something toward itself, right? Okay. Now, if there's mass around it like this, okay, right? It is like this, but think about it. It will be pulled by this mass in all the directions. Yes or no? Tell me, yes or no, right? So what will be the net? What will be the net? This. No, no. So again, right, Oves, that concept will be cleared in electric field, right? There are many things. Okay, there are many things. You are saying that, okay, what if it will be here? It won't be here. It will be uniform, right? It will be uniform. It will be similar at a position which is equidistant from this sphere. Okay, right? These concepts will be cleared more in electric field, right? I can teach in gravitational field also, it doesn't matter, but your syllabus does not allow that. Okay, so we will study all of these things in electric field, right? We will study what will happen if we have one hollow sphere in the other sphere, and what will be charge if a charge is inside this hollow sphere, right? So whatever you want to study, it is in electric field, right? And that time you can relate it with this concept that we are studying in gravitational field. Okay, everyone? Okay, so please have patience, wait for that, because it will take a lots of time. This electric field chapter will take around 1 month, and I don't have 1 month to spend in gravitation. Okay, because it is not required in this gravitational chapter. Now, this is your first homework. Okay, second is due to disk. Okay, due to disk. G due to disk of radius A and mass m. Mass m. Okay. Hint: this is solved as same as sphere, solid sphere. This is solved, right? Same as solid sphere, and the elemental area, right? The elemental area is taken as ring. Right? Is ring. This is the hint. Okay. Okay. So everyone got this concept? Tell me, guys, everyone got this concept, right? Okay. So if we see, right? So we covered point mass, we covered ring, disk. Okay, disk is something which is for advanced. We will cover the formula. I will discuss the formula with everyone, but derivation, okay, you have to do. Now we covered thin spherical hollow sheet as well as solid sphere. Okay, right everyone? Okay, so I guess everyone understood about field. Anyone have any issue about field now? Tell me, anyone have any issue about field? No? Clear? Clear everyone? Okay, very good everyone, very good, right? Let's see. We will take 10 minutes. Okay, I'll just take 10 minutes extra, don't worry, because I have to complete one small topic. Okay, yeah, this is very small topic, right? Okay, so next topic is variation of G, right? Variation of G, again, this G is accretion due to gravity. So what will happen to G? What will happen to accretion due to gravity, or what will happen to gravitational field intensity or gravitational field strength, right? When we talk about the changes in its position, right? Changes in its position. Now this is specifically for Earth, right? This is specifically for Earth, right? That's why I'm talking about accretion due to gravity. Now we know that as R changes, okay, as R changes, G will change. Yes or no? Tell me. As R will change, G will change. This we have already studied, I guess, in class 9th, but I'll explain this once again. So we have two cases, right? The first case is what if we take a point which is at a height h above the Earth's surface? Okay. What if we will take a point h at the height h, okay, which is above the Earth's surface, right? So according to this basic formula, the force will be this G m capital M small m by R plus h whole square. Yes or no? This is basic formula. You don't have to think a lot for this formula. Right, everyone? Tell me, right? And G will be what? G will be F by small m, where capital M is the mass of the Earth. Okay? Okay. So I will consider this as G naught. I will consider this as G naught, and this is G dash. Consider it as G dash. So just think about this. So G dash is equal to capital G M divided by R plus H whole square. Anyone have any issue in this? Anyone have any issue in this? No? So can I say that, okay, G dash can be written as capital GM by, now take R common from here. So we will have R square. Now if I take R common, I'll be left with 1 plus H by R whole square. Okay, everyone, there's a small maths here, right? Got it? Tell me, got it? So I can write it like this. Okay, we have G dash is equal to, now capital G, sorry, G M by R square is nothing but G naught. G naught, this is G naught into, now we have this, okay, we have 1 by 1 plus H by R whole square, right? This is basically G dash is equal to G naught 1 plus H by R to the power minus 2. Okay, till this point everyone is clear? Till this point everyone is clear? Raise your hand. Till this point everyone is clear? Yes, very good, right? Very good. Now here we have a concept, right? What is the concept? So if I'm having 1 plus H by N, 1 plus H by N, right? To the power minus something, minus A, right? Minus something, anything, right? If H is very, very less than N, if H is very less than N, or instead of N, instead of H, I'll write X, okay? It's better. If X is less than N, if X is very, very less than N, now then this statement can be written as 1 minus AX by N, right? This is from binomial theorem. Need students, just remember this. This is what happens, okay, according to maths. Okay, everyone, tell me, got this? What happens. This is what happens, right? Okay, right? So if you use this, I'll just rub some portion over here. If I use this concept, so can I say that, okay, we will get G dash is equal to G naught bracket. Now H is very, very less than radius of the earth. Tell me yes or no. If H, the height that you're considering, is very less as compared to the actual radius of the earth, then it can be written as 1 power is minus 2. So we will get minus 2H by R. So this is the formula. Tell me yes, right? Karishma, Chulika, Amish, Jasharan, Neet, Koshi, understood how come this formula we got here, right? How come this is converted into this, right? So this is the mathematics involved here. You have to remember this. Okay, see, you just have to remember this maths. If we have 1 plus x by n, if we have 1 plus x by n to the power minus a, and if x is very, very less than n, if x is very, very less than n, so I can just write as 1 minus ax by n. Okay, that's it. So this is directly converted into this. Okay, everyone? Okay, Karishma, Priyanka, Samya, got it? Okay, so this is for height h. This is for height h, right? I'll rub this. Don't worry, I'll share the PDF. I'll share the PDF which consists of everything. I'll share that OneNote PDF also if possible. Okay. Now, second one. If we talk about the depth, right? If we talk about the depth, if we goes distance h inside the earth, okay. So think about this, right? It is decreasing. Yes, it is decreasing or increasing. Tell me, G is decreasing or increasing? It is decreasing now, right? Now, what will happen if you go inside the earth, right? What will happen if you go inside the earth? Now, don't you think that if you go inside the earth, the formula will not be this? How many of you think about it, right? Because it is a case, if it is a case of solid sphere, yes or no? If it's a case of solid sphere. Now, when you talk about solid sphere, if I take any point outside the sphere, it is basically G capital M by this distance, Now this is R and this was H. So that's why we have R plus H whole square, right? But if I'm taking any point which is inside this, right, can I use this formula? Can I just say, okay, it will be Gm by R minus H whole square? Can I use this? No, right? A big no. Then you have to remember the formula. Yes, very good. GMR by AQ. Very good, everyone, right? Very good. So I cannot use that formula. Which formula I should use? I should use GMR by AQ. Agree? Yes or no? Agree? Anyone have any issue in this? Now, what is R over here? R is A minus H, or basically capital R minus H. The small r is this only, right? This small r is capital R minus H. So I can say, okay, G dash will become G capital M R minus H whole R cube. That is your formula. Agree? So in terms of G, I can just modify it as G capital M by R square into, we put one R inside, so we'll be having 1 minus H by R. So this is your G naught. So you will get this equation, yes or no? Tell me, yes or no? Okay. So can I say that the acceleration due to gravity or the gravitational field is maximum at the surface? Can I say that? It is maximum at the surface? Yes. And this is something which is not new. If you have observed over here, if you observe this graph, okay, wait, if you have observed this graph, right, this is the maximum point, right, everyone? This is the maximum point of this G, and this maximum point is at point A, right? So you can just conclude from here also. If you go below this, then also it will decrease, and if you go above this, then also it will decrease, right? Right, everyone? Okay, right? So I hope everyone is clear with this concept. Okay, so I will conclude till this point. Till this point. Still, till today, no homework. Just do your previous work. Homework is the two derivation that I gave, right? Need students try solved examples from the DC Pandey book, which I've already shared. Okay, and homework is, what is homework, right? Please watch all the videos. Please watch all videos, right, from Avanti Gurukula of this chapter. Okay, right? Okay, everyone. Okay.